Welcome to Pure Mathematics 1, Chapter 7, Trigonometry. Topic: Proving trigonometrical identities. So in P1 exam, you have to prove some trigonometrical identities. And here's are the two basic trigonometrical identities that you are given, and you don't have to prove them when you view them in exam. And they are given in the data booklet. And you also don't need to learn by heart these two equations because they are given in the data booklet. And you just need to know that they exist and you can use them without proving. And now to start with, I will prove these two to help you guys understand more and know why we have these two equations here. First of all, I will draw a right triangle. I have this size A, the length of this size A, this one is B, and this one is C. Here's my angle, theta. So first of all, I have my sine theta equal to A over C. And I have my cos theta equal to B over C. So this one will be sine theta square plus cos theta square equal to A square over C square plus B square over C square equal to A plus B, A square plus B square over C square. And you know that for any triangle, the sum of the square of the leg will be equal to the square of the hypotenuse based on the Pythagoras theorem. So this one will be equal to 1. So that's why we have this identities. Square of sine theta plus square of cos theta equal to 1. And this one you have tan theta. Tan theta equal to A over B. And you have sine theta over cos theta will be A over C over B over C equal to A over C multiplied by C over B equal to A over B. So sine theta over cos theta is equal to tan theta. And we have two methods to prove the trigonometrical identities. The first method is that on both sides of the identity look equally complicated. You can work with both the left hand side and the right hand side and show that the left hand side minus the right hand side is equal to 0. So for this identity, let's say that prove the identities of cos square of theta minus sine square of theta equal to, or you can say equivalent to, 2 cos square of theta minus 1. So here is the solution because these two look quite complicated at both sides. So we will take one side minus the others and prove that equation equal to 0. And we can have this one here. We have cos square of theta minus sine square of theta minus 2 cos square of theta plus 1 equal to 0. So simplifying, we have this one minus cos square theta, because cos square theta minus 2 cos square theta will be equal to minus cos square theta minus sine square theta plus 1. So minus of these combination here, but you know that this one equal to 1. So minus 1 plus 1 equal to 0. So these two are equivalent. And now we will look at the second method. So when one side of the identities looks more complicated than the other side, you can work with the side until you end up with the same as simpler side. So prove the identities. Cos theta over 1 minus sin theta minus 1 over cos theta equal to or equivalent to tan theta. when you look at it, this one is much more complicated and it's only one term. So you can work on this one until we get this one. So look at this part. Here we can rewrite this one like this. We use the common denominators, and then we multiply cos theta to cos theta. So we have cos square theta minus 1 multiplied by 1 minus sin theta. So we have it here. Now we have cos square theta. You break the bracket here, but sine theta minus 1. But cos square theta is equal to 1 minus sine square theta, because sine square theta plus cos square theta equal to 1. So you can change this one into this form, and then you have sine theta minus sine square theta. This one cancel this one here. They cancel each other, so you don't need to look at them anymore. And then you take the common factor, be sine theta multiplied by 1 minus sine theta, which then you cancel d2, and then you have sine theta over cos theta equal to tan theta. And now I'm going to prove this identity as an example for you guys. So I see here this side and this side. So for me, I would prefer the second method. So I would do for one side to make it into the other side. So I will choose this one first. I have 1 minus tan x square x over 1 plus tan square x. And I know that tan x is equal to sine x 1 minus sine x over cos x square over 1 plus sine x over cos x square, which is equal to 1 minus sine x square over cos x square over 1 minus sine x square over cos x square. Here, square here. And then I have cos x square minus sine x square over cos x square over cos x square. Here's plus, so cos x square plus sine x square over cos x square. And so I have here, because these two will cancel for each other, so I have here cos x square minus sine x square over cos x square plus sine x square. And now I know that this one equal to 1, so we don't need to use this one anymore, which is cos x square minus sine x square here. And I also know that cos x square equal to 1 minus sine x square. So I will substitute in there 1 minus sine x square minus sine x square equal to 1 minus 2 sine x square. So here is my identity. So the problem solved.